Okay.
This meeting is being recorded.
Right. Hello, everyone. Mouneem is beginning his presentation. Thank you all for answering the poll. And you can find the slides and the scripts in the chat. So we'll have Mouneem with us. Thank you for joining us, Mouneem.
Hello again, and welcome in this second part of our presentation about the analysis of medical data or medical sciences. So we started last time, but today we will continue because we didn't have enough time. So we will see in this course how to use data science and basically R to analyze different type of medical data. So based on the poll that I have shared now, most of people wasn't here last time. So maybe we'll go, we will do again the first part that we started last time. I will just do a quick presentation of these slides. So the plan is the following. So first we'll talk about biomedical data and approach to use to analyze the data. Then we have two applications. The first one is strokes predictions, and second one is the analysis of COVID-19 data. If we have enough time, so I will try to do both applications, but we will see it will depend on the pace and if you have lots of questions or not. And I prefer if you understand at least one of them, that's better than going through both of them, but not understanding. Okay, so I am a research engineer in the Cancer Research Center of Toulouse, France. I have a PhD degree in life science from France and a GCP informatics, and I work in the COVID-19 surveillance in Morocco. That's just a brief introduction of me. So the first question is why we need computer in healthcare. So I will give you directly the answer. There are two reasons. We saw this last time. The first one is the large size of data. So when we talk about medical data, it's one of the most challenging type of data in terms of size, because there is a lot of type of data. There is images, there is videos, some genomic data is very big, and we definitely need computers to analyze large size data, and it is not possible to do it by hand. The second reason why we need computers and data analysis in medicine and medical sciences is the complexity of data. So when we have already big data set and big data, we definitely will have high complexity and high, very complicated data to analyze manually. So we need computers to make the analysis automatic and to make the processing automatic. So we will avoid both. We will avoid human errors, and we will gain lots of times and human resource. So this was just an introduction of genomics. We will go back to it if we have time. I will go through this, and I will go directly to our part. Okay, so maybe this is important. So when we talk about medical data analysis, we have two branches. The first one is bioinformatics, and the second one is biostatistics. So what is the difference? So the common part is bio, which came from the terms biology, which refers to the natural science and the study of living organisms and the humans, animals, viruses, etc. The second part can be either statistics or informatics. So statistics is just the collection, organization, analysis of data, any type of data, while informatics itself is composed of two terms. Informa, which is informations, and matics is automatics. So these terms refer to the automatic analysis of information, of the automatic extraction of information. So if I go back to bioinformatics, bio is biology. So it's the automatic analysis of biological data. So we have two branches, if we can represent them like this. So I will have a data, I will build a tool using bioinformatics, and this tool will provide biostatistics to extract informations and usage to make decisions or other things. Okay, so I will go directly to our first example. So our first example in R is the predictions of strokes. So what we will do is that we will use a data set that we will download and use and analyze to make predictions of strokes, which means what are the variables and what is the probability that people will have a stroke based on different parameters, and I will see how to use this. So now we can start the presentation. So I have this link that you can use, or you can use the link in the GitHub. Maybe I can. Okay, so if you go to the discussion in Zoom, we will have the link. It's there. Maybe I can share my screen. Okay. Okay, so I think you can see the GitHub. This is the repository of the meetup presentations. So I think I have my code here, and this is the different codes used in this analysis. So this website is called GitHub, which is used to share data between different persons who want to work on some projects on some type of coding. So this is the codes that I have put. If you go back here, you will find different projects and different presentations of other people. So you have different choices how to use GitHub. So you can either click here and download a zip file. So this will give you a zip file with all this code, and you can use all of them. Or you can go to specifically one repository and select specifically one files to use in your code or your practice. So we start with part one, which is this one, and here you will find the code that I have prepared for these presentations, and you should save this file and save also the CSV file, which is the table that contains the data. So how to save this file? You can either, I think you can either download it by clicking here. This will open up this file, and you can just click on Control and S, and it will give you a saving options. Or you can do it manually, step by steps. You can copy, but for example, this part and execute it in R, and copy the second part and execute it in R if you want to do step by step. Or you can download the full file. So you will need the first one, and you will need this file. So the first one is part one, which contain the code that I will use, and you will need this file, which is the data that I will analyze. And when you will click on this, it will open a CSV file that's containing CSV is just a table. It's similar to Excel, and you can see here we have different columns. We have gender, age, ID is not important. We have work type, we have residence type, average glucose, BMI, smoking, and stroke, which is if this person has stroke or not. So our objective in this first part is to use this data about different patients to predict if a new person will have a stroke or no, which means, for example, this first one is male, he have 67 years old, he don't have hypertension. Maybe I should zoom so people will see. This column is if is Boolean variables, which means if a person have hypertension or no. If he don't have it, it will be 0. If he have it, it will be 1. This one is heart disease. If this person have heart disease or no, so it's 0 and 1 Boolean variable. And if this person is ever married, the answer is also yes or no. The type of work, the residence type, and different parameters. So all you need to do is to maybe just click here and save link to save this this file, and you should put them in the same directory, so you will get access easy. Okay, so this is the files that you will need for the first part. For the second part, you will need part 2 and code CSV and maybe another file that I will send it to you because I cannot upload it because it's heavier than the allowed. So okay, now I will open my RStudio and we can see this the code together. Okay, I think you can see it now. So while I am presenting, you can ask questions in the in Zoom. If you have any questions, you can put it in the discussions, and I will try to answer while we are going. So if you open the file that we have downloaded just now, it is part1.r presentations, and it will give you something like this. So what is R presentation is just a way to use R to make slides and presentations. It will give you 4 main panels. So this is the first panel, this is the second panel, the third and fourth one. So here I have the code. So if I want to write a code, execute, and other things, I will use this one. And here is the slides. So I am execution. I prepared this to be like slides, so you can follow and you will see that you have here the code and here the output of the code and what you are expected to have when you will execute this. So this is very useful if the person can't execute the code or have some problems in his machine. He can just follow using the slides here, and he can understand what will happen and what we are expecting as a result. So we can start here. So the first part is to load the data, which means, sorry, do you hear me or I have a problem? Can everyone hear me?
Yeah, we hear you. I think some
Okay.
people's internets are a bit slow, but otherwise you're fine.
Yeah, okay. If some people hear me, I think it's other people's. Okay. So as I said, this part is to load the data. So what is loading the data is to import the files that we have download just now. So the R code will understand that we want to use this data in our analysis. So here I have maybe 3 or 4 steps. The first one is set WD. What this means is just set working directory. So here you should change this with the name of the folder where you have the code. So for me, I have a folder with this name, so I should put this name. The second part is to read CSV. What is read CSV is just saying to the R code that I want to read a table, which is a CSV, and I want to store it in this variable which is called data. So when I have my data stored, I can show the head of the data, which means the first 6 lines. So if I want to execute, so here when you are using our presentations, you can execute group of code by small groups. So if I want to execute from here to here, I just need to click on this, and when it will be executed, I will have my output here. So as you can see, the first one was executed. So here I have two colors. I have the blue lines and the black lines. So the blue lines are the code that we will use, and the black lines are the output that was generated by the program. So the first one was executed without output. The second one was executed without output. The third one, we have something like this. So here we have just the table that we have just imported, and the first 6 lines, first, second, up to the 6th line are here. And if you can see that these lines are exactly the same one in the presentations. It's just this one you can edit, you can execute it manually, and this one are already generated by existing code. So the second part, which is str data, is just a way to tell R to show us the structure of our data. So if I execute, you can see that here it will give me this output, which is the same as this one. So it will say that the type of my data is data frame. It can change this number of observations and this number of variables. What this means? Observations mean that I have this number of rows, which mean lines in the table, which for us, each line represents one patient. And I have 5110 patients that I will use in my predictions. And for variables, it just means the numbers of columns of my table. So if I go back just here, you can see that here, 1 ID, 2 gender, 3 age, I will have 12 variables. And then it will give me the type of each one of these variables. So ID is int, which is integer, which just mean a number, small number with it can be either 1,000, anything. The second variable is gender, and the type of this variable is character, which can be either male or female. Age, which is also numbers. Hypertension is integer, but it takes just 2 values, 0 or 1. Heart disease is the same one. Ever married is character, which can be yes or no, and etc. You will see how to use them. So, okay, so this is the first one part. The next part is what is the gender distributions. So in this step, I want to see how many males and how many females I have in my data set. So how to do that? I will use a plot. So I will tell you. But this is very important part, because when we are working with medical data, to interpret any values we have, we should consider the characteristics of a person. So for example, if he is male or he is female, the output will change depending on this value. So here I want to, so this is just the type. If I use this, it will give me type of, it's just a way to tell R to tell me what is the type of it, if this data. So it tell me that it is a character, which is just the characters that I will print. Now I will use ggplot to make a figure or a plot. So what is the ggplot? So ggplot is a package that is used to make graphical representations in R. There is existing package in R, but ggplot allow us to use more advanced and a little bit easier way to make plots. So to use ggplot, I need to use library ggplot this way, and sometimes if this library ggplot to give you errors, mean that ggplot is not installed in your computers and you need to install it. And to install it, you just use install package and the name of the package you want to install. So if this line gives you error here or somewhere else, you should write this line to install ggplot in your machine. So for me, I have already ggplot in my my machine, and I have used the different parameter to make my plot. So ggplot, I need to specify some parameter to use it. The first parameter is the data set that I want to plot. So for me, if I go back here, I have stored my CSV file in a variable called data. So here I have import data as my first variable, and then I will specify the x-axis, which is this one here, where I have female, male, and other. And I want gender to be in my x-axis, which means just like this. Okay, so finally, I want to make a geom bar, which just tell that the type of chart that I want to generate will be a bar plot, which is bar. Okay, so here I have this output. I don't know if you can see this one, but maybe this one is more clear. Okay, so you can see that I have female, and I have a male, and I have others. So others can be either other genders, or if someone forgot to put his gender or want to stay anonymous or other things, it can be as other, but we don't have many one, we have just one observations which can be neglected. So as we can see that we have more females than males, and this should be considered in the next step of our analysis. So the next slide, I have just used some colors. So the plots will be more visible and more beautiful. So to add colors to your bar plot, you just need to change this. So this is fill, which means the color of filling of the bars that I plot here, and I want to fill it by gender, which means to each gender it will give a color and it will make this. So if I use, for example, color instead of gender, you will see that I have a gray color, but I have the color of border that is changed. So color mean the color of borders, but fill is the color of filling. So keep that in mind, just to if you want to change the borders and if you want to change the filling color, you can change just this one. Okay, so now I know my distribution of my my genders. I know that I have more females than males, but it is not a big difference. So the next step, I want to know the distributions of age, because again, in medical data, the output will change depending on age. For example, a child will have less probability of having stroke than a senior person more than 70 years old or something like that. So I want to see the
Hey,
distribution.
Mouneem,
Yeah.
Yeah, we have a question in the chat. Lawal, may you please
Okay, sorry.
what you're asking?
If the other is missing value, then can't we input it? So in the data that I have used here, I don't have missing data. I have it mentioned as other. So if I go back, so if I use this to plot the type of data that I have, then maybe I will table, and I will say data gender. So this will allow me to see the number of each variable. And as you can just zoom in, okay. So as you can see, I have in my table female number, other this number. So if I had an A, which means missing data, I should input it or remove the line or recalculate and predict what is the value or something like that. But in my case, I have other, which means the person that have filled the information preferred to maybe stay anonymous or don't give his gender or something like that. So I should consider this and maybe just don't include this line in my prediction because it will make some errors in the prediction, but it will not make a lot of, it will not affect the prediction because it's just one line, and I have already, I think 500 or something like that of lines, so it will not make big error. Okay, I think we have other questions. It can be an yeah, like that. So we need to respect their choice and keep the data maybe don't and that is that's okay. It's not just one line. It will not change in our analysis. Okay. I think if I get the question clearly, how does ggplot treat ggplot will treat non-existing data as another type of data, and it will add another column here. It will add NR, it will be shown here, and it will show me the number of data that I will have. I hope this answers your questions. So for the next part, we want to see the distribution of age, which means how, what is the majority of patients that have, or how the age change in our data. So to use this, I need to first to know the type of data I'm dealing with. So if I plot the type of age, the type of column 8, which is can change, will show me that I have double, which means these are numbers, continuous numbers that I have. And I need to use the specific type of plot to plot double data. So for the case of when we had here characters, which are factors, we used bar. But now when we'll have double, we will use density. So what is density is just similar to the bars, but it will give me a continuous plot that will show it in a continuous way. So it will be more visible and more easier to interpret. So here I can see that I have this plot, which is in the x-axis I have age, and in the y-axis I have density. And what I have in my code is that just x equal age, it's just the x-axis, and the filling, I just use the light blue. If you use, for example, green, change the color to green. And again, if you want to execute just this part of code, you can click on this. If you want to execute the full code from the beginning, you can use this one, which will execute everything above. So if I want to interpret this, I can read it this way. Most of the patients that I have nearly maybe 55 or 56 years old, which is the maximum value that I have in my graph. Then I have another wave or maybe summit here, which is near 75. So I have different distributions, but this is not enough to interpret the data because I need to combine both information that I have. I need to combine, okay, so I need to combine age and gender because gender alone and age, how is distribution of males and what is the distributions of females. And to do that, I will use again the geom density. Okay. 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 I think I don't have slides for this, but it's easier. So I just need to change the filling color from light blue to the filling to like gender. So what I did here is just I changed fill from light blue to gender. So when I will execute, it will give me something like this, which is the combination of both. I have here the females, I have males, and I can see how the age of females change and how the age of males change. So here I have a problem, which is the plots are overlapping, and I can easily add some opacity. So I just say alpha equal to maybe 0.5. So this is a way to add opacity to our graphs, so we can see through them. So here we can see that in pink, it's the distributions of females, and for males, I have these distributions. So I can see also that I have a bump here, which is the male child patients. I have a little bit more child males, and then I have nearly normal distributions of the other type of persons. So this is just what you see how my distribution is important before starting any analysis. I need to know what I am working with and how I will use it. So the next, for others, we don't have it in the plot because we have just one lines, and we cannot make a density plot from just one. We need at least 10 or more than that to make a clear density plot. Okay, so this is the same one, is just in another slide. So now we have finished this. We want to see how the variable gender will relate to strokes. So our objective, if you go back again, we want to make predictions of strokes, or we want to know which variables will impact or add probability of having the strokes in the future. So we start by visualizing how the change of gender will affect the probability of having a stroke or not. So we will again just use the ggplot, but before making the plot, we use some data processing. So here in the first part, I want to compute some frequencies. So I want to compute the number of genders and the number of persons in each gender that have stroke and the number of persons that didn't have stroke. So these functions, table, stroke, and gender, will will count the different variables that I have, and it will generate this table. So this is a table of frequencies. Each have the column, the rows here, and the columns here. And how I can read it this way: I have 2,853 females that didn't have strokes, and I have 2007 males that didn't have strokes, and one other. I have one female that I have 141 females that have strokes, had strokes, and I had 108 males that have strokes, which means this is the numbers of each variables that I have, and maybe it's a little bit difficult to read from the tables and try to analyze manually. That's why we use plots. We will use a plot to just make a plot from these variables. I want to make them more visual, so it is easier to analyze. So I have, okay, so maybe it's better to execute. So I will execute this line and this line and this one to make the plot. So this is another type of plot that will give me the same table that I had here, but as a graph. So it will be easier to interpret because I have different variables. So each number will be represented in colors. So if the value is low, I will have 0 or something like that in purple color. And if I have a value in the middle, I will have something in green or cyan. But if I have a high value, I will have yellow color. So how to make this graph? This is the code, how to make it. So again, I have used ggplot, which is the library to make the plots that we are using today. And then we have include a new library, which is called Variedis, which is just a library that allow me to make colors, which means this set of colors I can select them from here, so I can make the custom colors. So I will show you if I didn't use them much. So first of all, I have first parameter, which is data, is the data that I have just calculated, which is here. It's just the table that which can change the numbers. It's this one here. So the second part is x, what I want in the x-axis, and what I want in the y-axis, and the filling I want to fill by frequency. So this is just the parameter that I want to put here. The type of graph that I want to use is child, because this squares is called childs. So it will specify that I want geom child, and I will see that I want my color scheme to be following Vardis, so the default Vardis color. So if I didn't use Vardis, I will have something like this. So I will delete this line and I will execute. And as you can see, I will have blue, which can be difficult to read because I have different shades of blue, but it's almost identical here. I cannot make difference between this value. So various will give me more range of colors, and it will be a little bit clear that this value is lower than this or something like that, just to add some depth to our colors. So here, if I go back to the graph, you can see that I have a color here, and most of these values are purple, which mean are low values. So I can make a prediction that I have more patients that didn't have strokes than the one that have strokes, because I have in the 0 high values, but in the 1 I have very low values. I can't make difference between them. So this is called imbalanced data, which means I have more of a type than another type. And to fix this, I need to either divide this by the total number, so I have normalized value, or instead of using all the data that I have here, I will select few of them and use them as my analyzed data. Okay, so so this is for genders. What if I want to see how the age relate to strokes? So again, here we had three values. You have either female or male because it's factorial type of data. But okay, I'm sorry. But what if we want to see age, which is a number, and a continuous data? How we can do this? So again, when we had the characters, we used the geo bar, which is a bar plot that will make different bars, and now we have the choice. If I want to see a continuous data, the easiest way to do this is to use again the density plot. So I will now create a density plot, which is I think this part. Okay, so I will make a density plot with the x-axis is age, because I want to see how my data change in function of age, and I will just change the filling, the color, to stroke. The alpha is just for opacity, but the important part is the filling. So now I want to change the color according to the stroke, and if someone have had stroke or no. So the result is this plot and how I can interpret this data. So the zero in the pink color represents the patients that didn't have stroke. And as you can see, I have normally distribution. It's go up until the middle and then it goes down, which is the normal behavior of persons. I will have less people, less old people and less childs, and I will have a lot of people in the middle. But in the blue ones, the density plot in the blue, and I can see that I have more persons that had strokes are I mean most of people that had strokes are old people, which means when I start from above maybe 50, I see that the graph start increasing. I start having more probability or having strokes. So this can be our first observation, and we can see that we know now that age is the first factor that can add probability of having stroke or no, which is an expected value. Everyone knows that as we advance in age, we have more probability of having heart disease or uh, other disease. So now we want to combine both type of data we have seen. So we want to combine age, gender, and strokes. So we will use again ggplot to make the combination of three variables. But the question now, how I can represent three variables in one plot? So we know when we use two variables, we had the x-axis and the y-axis, and we can play with them with different type of plots, either density plot either density plot or geom bars. But now how can I can combine these types? So okay, so it's this one. So I have different solutions. The first one is to use facet wrap. So what this facet wrap will make, it will make three mini plots based on the variable that I will specify here. So it will take gender, and it will make a plot of each of the gender I have in my dataset. Then it will apply everything else I have mentioned here. So this is the same plots we have seen previously. It's the same one as this one, but just by considering the lines or the rows that have the value of females, then the value that have male, and the others. So now I can see more clear representations here, which will represent a normally distributed graph and increasing density. Again, the same one here, and increasing density. And I can see again that I have a little bump here for males, and I can conclude or interpret it as males have a probability of having strokes earlier than women's. Why? Because I have a higher value when it corresponds to maybe 60 years old. Starting from 60 years old, males have a probability of having strokes and heart disease, but women have later, have it later here. It's near 75 or something like that. But it's also depend on the data used in the analyze. This is use facet, which is facet grid. So grid will just simply make similar, but using grid, it will be like a table of values, and I will have here in the y-axis, x-axis, I have the gender, and x-axis, and I will have them here. So now I can see that I have each distribution visualized separately, and I can read it clearly. And this is very useful when we have more than 2 or 3 types of data. So okay, if there is question, you can ask me, but I think for now this is clear. So just to recapitulate, it's these two are the same thing to do to make the visualization. We just use different way to make it. If I want them combined, I will use facet wrap. If I want them separated, I will use facet grid. So okay, the next slide I want. Okay, so now we have seen 2 variables out of many that we had here. So we had 12 variables here, and we say we analyzed how strokes will be affected by age and gender. But I have more than more than 2. Maybe hypertension will affect, or maybe heart disease will affect more than age the probability of having stroke. And it will tell me if someone is married or have been married or no. And I want to see if this will increase the probability of having heart stroke or no. So this is the same code we saw earlier, because this variable is factorial variable. It's just yes or no. And if I visualize it, it will give me using the Young child. It's the same code with the various colorations, and it will give me this. It will give me that I have a high value here and a low value here, which is which correspond to 0. These ones, the yellow one and the green one, don't have strokes. But for the one, I have less people that have no, but higher value people that have yes, which means maybe there is a correlation between being married and probability of having stroke because I have higher value. But again, I should consider something else. I should consider that the probability of being married will increase with age. So maybe the persons who are here had strokes just because they are more old or they are more advanced in age. That's why they are married, and there is no direct correlations. So this is should be considered. Okay, so here I have a data normalization script, which can be used to make more normalized data, and I will go from this one to this one. So this is just a way to make it more comparable because I have more patients that had strokes. I can use data normalization to make the visualization more clear. And now I can see that I have clearly higher numbers of persons who had strokes. Most of persons who have strokes are married, and most of people who didn't have strokes are not married, but maybe just because of the factor of age and nothing else. Okay, so another important factor to consider is the BMI. So BMI is just the body mass index, which means it's a way to see if someone is overweight or it take in considerations the height and the weight of the persons, and it's just an equation that can be calculated easier. So we have the type of data that we have is numeric, which means it's a number. So again, use energy to make. So I will use genome density, and I will use two other parameters. I will use BME because the variable I want to track, I will use it in the x-axis, and I want to fill by gender, which means I want to change the color using the gender that I have here. And the output is this one. In the y-axis, I have the BME. As I go from the left to the right, the person will be more overweight and will be more obese. And in the left part, it's the person. So as you can see, I have two colors here. It will change according to the male or female. And expectedly, I have the pink value, which is a little bit on the left side. Why? Because expectedly, females will weight less than males. So this is the normal result. And I can see that most of my patients have maybe near 25 or at most 30 BME, which is the normal distributions. So this is just the distribution. Now, if I want to see, I'm sorry, sometimes I forget to pass the slides from here because I have different panels. Okay, so this is just the distribution, just to get an idea and to see if I don't have a problem with my data. And this is very normal because it's normal distributions, and the censure is the normal value. The next thing is to see how this variable will change corresponding to the strokes. So now I will use different things because I have I want to make predictions. So I will use in the x-axis stroke, and I will specify this time the y-axis as BME, and I will use genome point. So what genome point is just a scatter plot. It will make the plot, and it will put a dot in every patient according to the values. So the output is something like this. Here in the y-axis, I have the BME, which is the weight, and here I have strokes. It can be either 0 or 1 because I have Boolean values. These patients didn't have strokes, and this one had strokes, and this is the distribution. This graph is not very helpful because I have lots of points that are overlapping each other. So this is not very visible, and it will. I need to do some changes to make it more easier interpret. So the change I can do is I can use geom jitter instead of geom point. So jitter will just make some space between the points instead of overlapping them. It will add some width. So I can see now that I have. It's clearly now that I have more data, and it is more overcrowded here than here where I have more spaces, and this is again a problem that we had earlier because I have more patients that didn't have stroke. So this is why I have this. But again, I cannot interpret this with my eyes because I have lots of data here, but I don't know if most of patients have value here or here. So I need to add something else. So the thing that I will add is a box plot. So I will use the function geom box plot, which will make a box plot graph, which look like this. Okay, okay, so yeah, here. So the box plot is just this box here, which will give me some information. So the information that I will have from the box plot is the median value here, which means my patients are distributed over this y-axis, but the middle value, if I take half of them, the half will be here, which means the expected value will be near maybe 27 or 26, which is a normal thing. If I go to the other column, which is the patient that had strokes, I can see that the middle value, the median value is here. And I don't know if it is visible for you or no, but the value here is slightly higher than this one, which can be interpreted as the patients that had strokes are a little bit more obese than the patients that didn't have strokes. So we can see that this is another factor that we can add to our analysis. So we can know now that the gender, the age, and the obesity will affect the probability of having strokes or no. Okay, so this is the same graph. Okay. Okay, so now the question, how I can again combine the data that I saw earlier. And the question is how early obesity will impact the probability of having stroke, which means if I have an obese child, do he have or will have more probability or less probability of having strokes? And of course, this is again just to see the correlation between different variables. And it can be easy done just by specifying the parameters here. So so here this is just the code here. So I have the ggplot. I have in the x-axis I have age. In the y-axis I specified the BME. So I want, instead of strokes, I want to have BME and the age. And I want to color by strokes. I want to visualize different patients by different colors, and I want to make a geom point. Maybe I will execute just this one. Okay, so this code will give me this. Here I have two things. I have the BME and age, and I have strokes with colors, which means each blue color here would represent a patient that had strokes, and the the red colors will represent the patient that didn't have strokes, which is 0. But the problem again, because I have imbalanced data and it is lots of data here, I have overlapping points and I cannot clearly see the blue colors. So the solution is again to use facet wrap, or either facet wrap or facet grid. As we saw earlier, it allows us to do almost the same thing, but it will help me to separate the two plots and make them this way. Maybe I can also specify the number of columns to 1 if I want them to be one over the other. So this is just easier way to visualize them. And now I can see this is uh, the patient that didn't have strokes, and this is the patient who had strokes, and I can see a clear correlation with age. I can see that most of the blue points are here, which means there is a correlation between age and strokes. We already know that. And I can also see the BME. If I see the BME, I can see that there is different distributions here and here, different distribution of BME and strokes. But I have a point here. So this point can either be an outlier, which means something rare that don't happen every day, just a rare case, or can tell me something. It can tell me that someone who had less than 20 years old and had a body mass index of 20 or maybe 30 had strokes. So he was someone young and with normal body mass index, and he had a stroke. So this can tell me that maybe there is not a clear correlation between the age and BMI. Maybe having early high body mass index will not impact the probability of having strokes. But as you can see, it is difficult for me to interpret point by point and read all of them and try to make conclusions. So the solution is to make a model. So what the model will do is it just will try to find the best representations of all the points in one line. So in my case, I will use the ggplot to make this representation. So the function is geom smooth. So what smooth means? It will just make a smooth line that will try to pass through all the points that I have. So if I execute, I will have something like this. So I will just make it bigger. So as you can see, this one is stroke 0, which means the patient that didn't have stroke. And I have a graph that's going this way, but it's not important for us. For the one, I have this smoothed value, which tell me that I have near constant value here. So the graph go directly without changing. Then it will start decreasing with the time. So again, we have in the y-axis the BMI, which means a decrease mean a patient with less overweight. So this is in contradictions to what we saw earlier, which means that there is no correlation between age and BMI and stroke. So being older will add your probability of having strokes. Being overweight will add the probability of having strokes. But there is no correlation between them, which means if you have combined them, you will not have a more probability of having strokes. So, so in the next slide, okay, we saw this. Okay, so in the next slide is just okay. So this slide is just show how to make the visualization of all the type of data in one with one code. So instead of using each two variables at time, this okay. So these functions will allow you to make the visualization of all of them in one, so you can see more rapidly how variables correlate to each other. So the first thing I did is just I converted characters. My variable, I converted them to characters, so it will not give me errors. So all factors are converted to characters. Then I use pairs. So pairs is functions that will produce a matrix of scatter plots. So instead of using 2 by 2, it will make a lot of combinations of scatter plots, and from them I can maybe get an idea more clearly to how my data correlate to each other and how data correspond to each other. For example, this age, I will have age here, and I have, for example, maybe I can see gender. So if I want to see the correlation between age and gender, it will be here, and I can read it. It is not visible here just because the plot is small, but of course in your machine you can adjust the zoom to make it more visible for you. Okay, so this is one way to use it. The other way to use it is to make the machines learn to give the outputs. So what this means that we will use machine learning to analyze our data and make the predictions instead of us. So the general workflow will work as following. We will give data to the model, which is machine learning is the model. The machine learning model will make predictions based on this data and based on the input. So this means that my data is the data that I already know, that I have been analyzing, that I have imported. The input data is, for example, a new patient. When someone new came to me and he tell me that I have this age, I have this gender, I have this body mass index, and using the model, I can tell him if he will have a stroke or no, based on similar profiles of that patient that I have, which means if the patient is maybe young, is maybe 18 years old, and she is female, and she is not married, based on the model that I have, I will say that we have more probability of not having strokes in the next maybe 5 years or something like that. So now I show you the code how to make these predictions. So the first part is just set working directory and reading the data is the same thing, is the same data, there is no change. This one is just to convert the variables that I had as genders to factors. Instead of having a different type, I want them to be factors. So what factors mean? It just mean type. Instead of having characters which are word, I want them to be types, to represent types. For example, for gender, instead of having characters, I will have two types of genders or three types, something like that. And I want to convert the ME because it's not a factor. I want to convert it to numeric. I want it to be a numerical data. So I have in my code different steps that you can follow and reproduce the data, but I will go through them a little bit rapidly because we don't have enough time. So the first one is GG misvar, which is a plot that will tell me which lines of my data have missing data, which means have this value in A, which means which columns have missing data. So if you see here, you can see that I have this graph. It will tell me all the columns that I have and how many have missing data. So I can see that all the 11 types of columns that I have are aligned with the 0, which means don't have a missing value, except for the ME. So the ME, I have nearly 200 missing values. So I need to do something to fix the missing value of BME. So when we talk about missing values, it means that maybe I don't have the data or the patients don't want to share his data or something like that. So I need to fix this before going to the next steps. So one way to fix them, the easier way is to delete all the lines where I have missing data, which means I just will tell my code if you don't have this line, just remove it and don't consider this patient. But another way to do this is to input the data as one of you told me in the chat. Uh, slide. I will share with you the slide. Someone is asking, I think, in the chat. So uh, as I said, one way is to remove, another way is to input the data, which we will do now. So what I did here is I calculated the average BME by gender, and I replaced the missing values by the average value of each gender. So which means if maybe it will be easier if I show you the table. So this is the data that I have. It's stored here, and as you can see in the BME, I have missing value here, here, and lots of rows. So for example, for this one, what I told the program to do is to go first here to see the gender. So here I have a female that is missing value, and I want to replace the missing value with the average BME of females. So at least I will have predictions of the value that I will have here. Okay, so how it is done? It is done using group by. So group by, I want to group by gender, and I want to summarize. Summarize is just I want to calculate for each group the mean of BME in the lines where there is no NA. So if I execute this line, Okay, I think okay. So as you can see here, this is the calculated BME, and it will tell me this information. The average BME for females is 29.1. The average BME for males is 28.6, and for others is not important because we have just one, so this is justified. So once this is calculated, I will replace each BME by its according value using these lines. It is just if else, it's an easy function to use. So now if I go back and execute this line, you will see that I will have 0 missing value in all of them because I have used one way to replace the data, which is using the mean values. You can use different type of inputting techniques, but these ones work for me. So you can use different ones, it's fine. So in the next steps, I will go back here. Okay. So now I have no missing data. I need to pass to the data pre-processing, which means I need to prepare it for machine learning. So the first thing I want to do, I will split my data to 2 types of data, train and test. And what this means, it means that I will hide 20% of my data, and I will use it to test if my predictions are accurate or not. So I will show some lines to the model, and I will tell him try to learn the important factors from this data that I give you now, and then I will give him the rest of data, the data that I hide, and I will tell him, and I will see, and I will check how many predictions, correct predictions he made, or how many errors he made, and how I can assess this. So the first program we use here is a machine learning using random forest. So random forest is just like it's like decision trees. It will make the decision based on common factors. So here the library I use is called random forest. Again, if you have the library installed, you just run this line and it will give you that the package is attached correctly. If this is not installed in your machine and you have never used it before, you can use install that packages and specify the name of the package here. And this line will allow you to install any package you have. So for me, in my case, I have already the package installed. So I will just run this. Because I didn't. It is important to respect the steps, because if a step is not executed correctly, it will give you an error, missing data or something like that. So here, when I will execute this now, okay. So okay. So here we have the program that is running. As you can see, this is the function that I used to make my program. So the function is called random forest, and here are the parameters. The first parameter is the column I want to predict. So for me, I want to predict the strokes. So the column strokes I want to predict it, which is this one. So this is the prediction that I made. The second parameter that I can say is minus ID. I want to make predictions, but I don't want to include this column. Why? Because these are just the ID of patients, that it is not very important. It will not affect our data. Then the data frame that I'm using data train, the split that we specified. Then this is just two other parameters that I will give to random forest, which is the number of tries and the number of trees that he need to do to make his learning. And when this is executed correctly, it will give me something like this. It will give me, this is the function that you have used, and this is the out of bag error rate. So I have 4.7% probability of having error, which is something good. I think we have less than 5% of probability of having error, which is something good, but we can make it better by adding some other parameters and running multiple tries. So the organizer just told me I have less than 3 minutes. So I will go through this rapidly. So this is a way to make different random forest, and it will choose the best one based on the printed values. And you can use this model to make predictions. Okay, so this is just maybe you can use this one. So after running the first part, I choose the best model to make my predictions. So here I will use the function predict to make predictions. I will use the data, the test data. So if you can see, I will use this line. I will use, for example, the patient number 4. She is a female. She is aged 52 years old. He had hypertension. He don't have heart disease. She is married. She is self-employed. She lives in urban residence type, and she have all this type of data. And I want to make predictions. So all what I need to specify is the model that I have made earlier, and the new data that I have here. So it is from the test data set. And to make the predictions, I will just run this line, and the line will tell me that the prediction is no, which means based on these parameters here, these persons don't have the probability of having a stroke or no. And maybe if I change, for example, if I use patient number 10 and I execute, it again tell me no. It will depend on the variables used in this analysis. So this is all for the first part. I don't know if we can start the second part. Simi, do we have time or?
Hi. Unfortunately, we don't have time for the second part.
Okay.
Unless you're willing to come back for part 3.
We'll see. We'll discuss this and see your planning, and maybe we can. So in the second part, I have some COVID-19 data. So
Okay,
if
that
this
would be
is
very
interesting, we
interesting.
can see how to work with. Yeah.
Yeah, I think if we like you said, we can talk about it and we can see if, because the COVID-19 one sounds very relevant. It will be very see. Right, and I think that comes to the end of the presentation. Is that right, Mouneem?
Yeah, I just want to see if people have questions or
Okay.
something else. They can.
All right.
You
Yes.
can
If
take
anybody
questions.
if anybody has any questions, please feel free to write in the chat, or you can.
Can you push again the link of GitHub, because there are some people who are asking for the code. So for the code, it is available, but you need also to download the dataset. I have in here. I will put the code. So it is an R presentations. So you can see the code, and you can see on the right part here, you can see the expected output here. So it will be easier for you when you edit something. You can go back and check if it is correct or no. So okay, welcome. Do you have any questions, or if I missed something in my presentations, you can ask me now. Yes, Simi, you can continue.
Okay. There doesn't seem to be any questions because everybody was asking while you were presenting. I think everyone's questions have been answered. Mouneem has just
no, there is some people who are sending me direct messages.
Oh, okay.
So for the past machine learning, I have performing in the. Okay, someone want to be in touch? Yeah, of course you can send me message, and if I can help, I can assist you while in machine learning or other type of medical data analysis or genomics. Yeah, maybe you can put, if you want, if you have questions, you can put it in the general chat so everyone can see it, and maybe there is other people who can help you.
Hey, Mouneem, may you share your contact information with everyone?
So I use Mouneem in everything, LinkedIn, Twitter, anything. If you search this ID, you will find me. GitHub, I have this ID everywhere. So maybe LinkedIn or Twitter, I can answer your request without no problem.
Right. Okay. Is there anything else you'd like to add, Mouneem?
No, I think it's clear. If anyone have any questions, maybe we will see if you can. There are some people who are interested in the COVID-19. We can arrange maybe next month or something like that.
Yeah, maybe next month when you're available, definitely, because the COVID-19 will be very interesting to see.
Yeah. Okay. Yeah, I will try to find some time. Yeah. Okay.
All right. Right. Thank you, everyone, for coming. It's been a pleasure, Mouneem. Your analysis was fantastic. I've just been looking at your code, and you described everything from GitHub, how to import it. It's been very insightful. Thank you so much.
Welcome.
Thanks, Auntie. We'll talk. Edson is here, our other R user group brother. He has a presentation next week, Saturday, about data analysis. So I hope everyone will be able to attend, and we'll keep in touch with him.
Yeah. Thank you, everyone, for assisting.
Thank you, everyone. Bye-bye.